Good morning. We can get started here. I'm going to hit restart. My name is Eric Wallstrom. I am a program manager from Windows Active Defense, and this is my colleague Yolando. Windows Active Defense is the team that builds Defender, among other things. You probably know us more for that. Today, we are going to spend a little bit of time talking about ransomware, what it is, how it works. We'll give a couple examples and walk you through how they work, as well as talk fairly in depth about some of the protections that Microsoft offers. So why don't we get started? We'll start with a little bit of background on ransomware. I work for the research team, and the research team is responsible for a lot of the low-level reverse engineering and telemetry work that we look at ransomware. And wanted to start with a couple of little graphs here. First and foremost, on the left, we have a graph that looks back a couple years and looks at ransomware families. Now, a ransomware family is a term that we use that represents a common set of versions of ransomware. So when developers start writing malware, they will release their first version. We will hopefully detect it, and we'll give it a name. And so you've heard of a lot of these names, a lot of these families. WannaCrypt, Petya, Locky, there's a bunch of these, and we'll talk through those in details. But what you see on this graph are the number of individual family detections we have per day over the last couple of years. And so this is some measure of growth of ransomware as a trend. Going back about 2 years, you saw we would detect around 50 families a day. And there's been about 40% year-on-year growth over the past 2 years. Right now, we tend to see on the order of about 120 different families. And that's pretty substantial growth. If any of you guys work in the software industry and your company was seeing 40% year-on-year growth, that's pretty darn good. And I don't think anybody else has seen that today. And there's sort of a natural question as to why we are seeing that now. Why is ransomware an issue today, where it wasn't necessarily as common, say, 4 years ago? Still existed. And the real answer is that it's a business. Ransomware is first and foremost destructive malware that is a business. If we go back a few years, really this trend started in the 90s. The first version of ransomware that we saw was something called the AIDS Trojan, and it came out in 1989. And it was sort of a very poorly written, non-professional version of ransomware. The encryption algorithm that was used was hacked together and could easily be decrypted. But these guys got better. There were more and more versions that have been shipping through time. We started to see PKI infrastructure get used in the late 90s. But really, as a business, you want to get paid. And historically, there had not been a mechanism that would allow you to get paid in a completely anonymous way. And the big thing that's happened in the last few years are cryptocurrencies. Cryptocurrencies, Bitcoin came out roughly 7 or 8 years now, if I'm not mistaken. And in 2013, some of the bad guys started to take advantage of this. And the first versions of malware that utilized cryptocurrencies and Bitcoin in particular started to show up around 2013. There was a version that was out there called CryptoLocker, and it was really the birth of the industry. CryptoLocker used Bitcoin, and from there on out, we saw huge amounts of growth. And again, the reason here is they now, the bad guys kind of now have a way to get paid. Now we talked a little bit about the families. We get pretty good telemetry. Windows Defender has a feature called Cloud Protection, and for those of you who have used Cloud Protection, it is sending information to Microsoft all the time. And if there's nothing else you take away from this talk, turn on Cloud Protection. It gives you protection much, much faster. Nothing else comes back. Remember, nothing else I say, turn on Cloud Protection. What we have on the right here is a little video that we put together that shows sort of ransomware behavior through time. These are the last, I think, 22 months. We counted up the number of detections that we had on all of our machines that are sending us telemetry, and plotted them just as a function of location. And you can see this sort of pattern of we'll have a few months where things will go down, and then we'll get a big eruption. That was WannaCrypt, that was Petya, and it comes down again. We see this real pattern of waves. So Big takeaway here is a lot of growth, and we're seeing this behavior in waves. The waves are active developers writing ransomware, and you can almost see their development cycle. On the economic side, it's quite difficult to put real numbers on the impact of ransomware. There's a few things you might want to know, like how much money are people paying, what percentage of the people actually pay the ransom, what percentage of the people that pay the ransom actually get their data back, and if you didn't pay the ransom, what's the cost to you? And it's not surprisingly, because these guys want to remain anonymous, want to remain sort of in the shadows, we don't have a real clear number that says there's X million dollars being paid per year or there's X billion dollars being paid per year for ransom. But we do know a few things. First, whatever the amount that people are paying, it's in the millions, it's in the hundreds of millions of dollars, if not billions. This is a business now, and these are professional developers who make their living by writing variants of ransomware, sending them out, waiting until the AV companies figure out how to block them. They go on vacation, come back a few weeks later, tweak their code a little bit, and send them out again. They're making a lot of money, and it's attracting good developers. There's ROI here. Secondly, however much money these guys are making, the amount of money that people in this crowd and their companies are either paying or are impacted in terms of recovery costs, lost business, downtime, dwarfs that by far. When the Petya outbreak happened in June, we had an opportunity to talk to some very Fortune 500 scale companies, and some of these guys were literally down for a few days. And if you took Microsoft down for a few days, for example, that would be a huge impact in terms of revenue. So there's billions of dollars of impact here. And finally, I want to reiterate the fact that cryptocurrencies are sort of the trigger here. They have been, they are the way that guys are getting paid. So let's transition a little bit from kind of high-level info about ransomware and talk more about protection. I mean, that's what the Defender team does. That's what WYED does. And we'll talk a little bit about Microsoft's high-level approach to protection. And we'll talk a little bit about protection technologies, but mostly want to give you a sense of how we view the problem and the approach that we're taking to solve it. So this is my little graphic. These skull and crossbones are obviously the bad guys. We have a few primary attack vectors: web-based, email-based, and we call network-based, but these are really exploit-based attacks. And the general goal here is we have a three-layered approach. And we're trying to have, we will continue to have a lot of attacks, but we want the ones that get through, the ones to be successful, to minimize things. So the first is attack surface reduction. And this is for those of you who have been to some of my colleagues' talks on exploit guard or app guard, this is an attempt to make you less vulnerable. AVs are great. We detect things, we block things, but if the ransomware never has an opportunity to run in the first place, that's much better protection. It doesn't rely on signatures, it doesn't rely on anything other than you all doing your job to lock down machines. We have a bunch of different ways to do that, and we'll go through some of those protections in detail. But if we're successful here, there should be very, very few attacks who get active on the machine, run, and can do damage. So if an application or if malware, ransomware does get active, we need to be able to react a lot quicker. And there's a bunch of different ways that we are doing that. We have the behavioral engine within Defender, but cloud protection is probably the best way. It's something that allows you to avoid even zero-day attacks. When we see something on the box that we do not recognize, we'll call the cloud. The cloud will look at all of its telemetry, all of its data, reason over the behavior if necessary, and give you protection in real time. So reducing that time to protect both limits the spread of malware, but it also stops active malware on the box from being as effective, as impacted. If we can detect things faster and block things faster, even though we missed it, even though these things got active, the impact will be less. And finally, and we will talk, and Yolanda will talk about this towards the end of the talk, we want to be recoverable. Now, this is a very easy thing to say, but there are ways we believe that if you can get your system in a state where you are always in a recoverable state, where if you drop your laptop in the lake, you can always get all of your data back, it really changes the economics of the deal. The whole idea here is let's make sure that there's never a reason to pay. Yes, it's annoying to have to go recover data, whether from a backup, whether from the cloud, but if you are in a position to always recover your data, it changes the economics of the process. We'd much rather have those bad guys writing either other forms of ransomware, or my team, the research team, is always hiring. If you guys are any ransomware authors there, feel free to give up, come talk to me, and we'll get you hooked up fighting these guys. If that works, then obviously the number of impacts that happen are minimal. And so that's the general threat. Attack surface reduction on the top, being able to reduce the time to protect in the middle, and when all else fails, good recovery capability. So let's talk about what are some of the protections that Microsoft offers. This is sort of a busy slide. I'm going to walk through each of the pieces very, very quickly. There's a lot here. For those of you who are interested in any particular protections that we talk about here, there have been sessions on many of them, and I would recommend you go back and look at some of the videos or the slides from those. So left to right, we have pre-breach situation. This is technologies that will block ransomware, block malware before it ever gets to your box. This is what we're going for. All the way onto the right, post-breach, what do you do if you were attacked and you need to recover? So, off machine, O365, we scan something on the order of 2 billion emails a day. This actually blocks a huge fraction of the ransomware that is out there. And so getting your email in the cloud and O365 as protection is fantastic in that regard. Edge, for those of you who don't use Edge, Edge is fairly clearly the safest browser that is out there. Edge has a bunch of technologies to harden it from attack, as well as things like Smart Screen. Smart Screen is our service that is a reputation service for bad URLs. It will block URLs coming down. There's no configuration you have to do here. You simply use Edge, and known malware sites, known ransomware sites are blocked before they ever get to you. Use those off-breach or off-box protections if you can. Now, coming back to a little bit closer to my neck of the woods, lockdown devices. How many of you are familiar with Windows 10S? Anybody tried it, used it yet? We've got work to do there then, apparently. 10S is a lockdown OS. It will only run apps that are secure and coming from the store. This will be a great win for those of you who can take advantage of it. There are certainly a lot of information workers who can. The store is growing every year, and we have a lot of apps in there. We also understand that it won't be for everyone. As a result, we have something called application control that allows you to lock down which apps will run on your device on a regular 10 installation. Attack surface reduction rules. This is something that is shipping. The brand name here is actually Exploit Guard. There was Misha and some of my colleagues did a talk yesterday. ASR allows you to apply particular rules to limit the scope or limit your attack surface on box. So naming a couple, for example, it might be really rare where, for example, you might want Word to launch a second application. That's a typical attack vector. A Word macro will be used to download a file, a binary, and launch that binary. If that's something that doesn't need to happen in your organization, you can turn on that rule. You will be safe from it. A little bit farther to the right, controlled folder access. This is another feature of Exploit Guard, which Yolanda is going to be demoing a little bit later. This allows you to designate folders that are locked down for writes. So if you have, for example, a backup folder, only the backup executable that you use should ever be writing there. Nothing else ever should. Turn on controlled folder access for that folder. The malware may run, but it cannot write to those directories. AppGuard. AppGuard uses virtualization technology to induce a container to run in your browser. So if you do ever go to malicious sites that try to download executables, that executable is downloaded into a container from which it cannot easily escape. And then network protection. This is the third major feature in Exploit Guard. Network protection blocks outbound connections. And so if you have a piece of malware that is going to talk to a command and control server, it won't be able to make that outbound connection if we're familiar with it. And this works on multiple browsers as well, right? So Smart Screen works on Edge, but this includes outbound protection for Chrome, any other browsers as well. So Defender AV, this is what most of you guys know as the protection service within Windows. We are constantly iterating. We are working to make Defender the best AV that we can. One of the ways that we have done that is with the behavioral engine. You can see this is a little bit over to the right, and it's under the post-breach section. If you do get malware running on your box, the behavioral engine will look at the sorts of things that it is doing. And incidentally, for the demo that we're going to do a little bit later, we have been writing some of our own kind of pseudo malware, and it became difficult to actually do the demo because Defender kept blocking our own software from us. It works. Behavioral engine is a great option for detecting behaviors that look risky, such as encrypting files and deleting them. Let's see. And ATP. ATP is a poach breach technology. ATP is a piece of code that runs on Enterprise Edition. It's part of the E5 offering. There's a client that runs, or a service that runs on all of your endpoints, and they are emitting data about detections. This could be static detections of malware. It could be something simple as a particular network or outbound connection is made to known bad site. It gives you a single pane of glass to view all of the activity on your machines across all, the entire network. You can slice and dice by users. You can really drill down on what has happened, which is great if you do have, or if you are impacted by malware, because it effectively points at what you need to do to clean your network. And finally, Offbox. This is the bottom part of the funnel. OneDrive, for those of you who have been to any of those talks this week, have announced a point-in-time recovery capability. This makes it very, very easy to get your data back. And this is another piece that Yolanda will be talking to in the future. So let's talk a little bit about some case studies. I think this is some of the more interesting stuff. How many of you have either been impacted or have heard of Locky? All right, we got a good number of customers. We're going to do a couple of case studies, and the first one is on Locky. Locky is sort of the prototypical piece of ransomware. It's been around roughly a year and a half now. We saw our first detection starting in February of 2016. It's a piece of encrypting software. There are other versions of ransomware out there. The big ones that you can hear about tends to be the encryptors these days, but there are lock screen ransomware, things that'll keep you from booting. Encryption is good because it really does work. It keeps you from your data, and it also keeps the box alive, which you may need if you want to actually pay the ransom. If you pay the box, there's no way for people to pay. Uses Bitcoin. I checked just before the talk. Bitcoin was around $4,100 or so a piece, so they're asking 0.5 Bitcoin. You can do the math. A little over $2,000 to get your data back. It is a very prevalent piece of ransomware, and it is a very profitable one as well. This is, in fact, the ransom note. If you ever see this outside of this talk, you are in a bad place, and I am sorry. But let's talk through how Locky works. So like most variants of ransomware, and certainly not all, and we will talk about some of the exploit-based versions later, Locky is a social engineering attack. And they use email as the vector to send, to trap their, hesitate to call you customers if you are, but yes, to trap their customers. Vicious email goes out. There's a lot of different ways this happens. Some of these will be through botnets, but suffice it to say they have many ways to send out malicious emails. And these are very targeted. They can be targeted to individual users. They can be targeted to particular industries. Anything to get you to read that piece of email. And the email will have either an attachment or a link or some piece of information that is going to either download or execute content on the machine. And turns out that people will really click on these sorts of things. It always sort of surprises me when I hear these sorts of things. Verizon did a study in 2016. They sent out a bunch of sample phishing mails. Out of 100, you guys may have seen some of this data, 30 people would actually read the mail. And of those 30, about 12 would actually click on whatever was in there. Education campaigns are great. We recommend people to try to educate their users, but at the end of the day, they simply don't really work. And when you do send out these email campaigns, this would happen within about 3 or 4 minutes. So it's very, very quick. It happens aggressively. So we have a piece of mail. You can see I have a Word doc, I have a PowerShell script, JavaScript, a zip file. Any of these, all of these have been seen associated with Locky. And for whatever reason, a user is going to click on one. Different security environments may or may not pop up warnings when they do this, but people will ignore them. And when they do, the script gets running and it communicates with the command and control server. This is actually, for the network protection piece, this is the piece of the kind of attack chain, the kill chain that we're going after. These sorts of connections are blocked. Command and control servers are short-lived typically. They pop up all over the place. And the command and control server is the thing that actually brings down the virulent binary. It's a binary file that actually runs that does the encryption work. The file comes down, encrypts your data, and then pops up the ransom note. And here's our skull and crossbones guys. So that's the typical attack chain. Starts with an email. Some sort of link or attachment comes down. User executes it, and they are caught. It's a social engineering attack, and it's very, very effective. Doesn't necessarily get the headlines like some of the other ones that we've seen in the last few months, but this is the bread and butter of the industry. So I took some time to go look at data. And this is Locky's encounter rate. So we talked a little bit about the telemetry that we get when you opt into cloud protection, and you guys are all going to turn on cloud protection for those of you that are using Defender. And we can see a pattern here. We can see very clear pattern of something is released, prevalence goes up, comes back down again, there's a little bit of a pause, another one comes up. And this is sort of the signature, this is a development cycle. You can kind of see the developers actively working on things. This, by the way, is 1 year of data. This is 2016. You can see V1 started in February, and it was a very simple piece of malware. There was really no obfuscation. We fast forwarded a couple months. They started doing more and more complex things. They started hashing registry entries, tried to obfuscate a few things. They changed the config format. 2 months later, these guys went on vacation. They ran out of money. They came back to work. They came up with a new config format. They started encrypting the communications with the C2 servers, the command and control servers. Another vacation and another set of Locky, another version of Locky. More encryption, more encoding, changing file extensions. This behavior of kind of this cyclical behavior, we just keep seeing it. We see it not just with Locky, but lots of different variants, lots of different families out there. The message here is these guys are professionals. These guys have a development cycle just like anybody else. And the clear reason why is that AVs go after this sort of thing. We have a cycle that historically AVs work by, you have a research team, they will examine a piece of ransom or malware, they will develop a signature, they will publish the signatures down. Anytime that a file that matches that signature is seen, they will block execution of it. That's sort of the history of the industry. That's what we've been doing for 20 years. And these guys just try to stay ahead of it. If they can be a day, a week ahead of that virus signature, they'll make a bunch of money. And then they go on to change things a little bit. These cycles are getting shorter, and as the problem grows, we've seen these cycles compress. It really means that a traditional AV is sort of not the solution here. Signatures are great, they're necessary. I'm not suggesting that signature-based AV isn't an important piece of software to have, but they're not going to solve this problem. We need to look at different approaches. So let's talk a little bit about the next case study I want to talk about. This is Petya, also known as not Petya. The confusion came over the fact that there was a version of ransomware called Petya that came out a couple years ago, and the not Petya one, which is the one that you guys are probably familiar with if you're familiar with anything, stole some code from that and had some behaviors that were very similar. So this was June 26, 27 in local time. I learned about Petya on my drive home or to work in the morning. And this was on NPR, and the next 48 hours of my life were very, very busy. I didn't really expect to learn that I'd be spending a lot of time in the office from NPR when I started this thing. Petya was a big deal. It did massive damage to a few countries and a lot of companies. This is a graphic of Europe where the majority of the damage happened, but it was a global event. Now we got one more graph I want to take you, to have you look at, and this is essentially that same graph that we saw with Locky. But there's one thing that's sort of critical here, which is, whereas Locky happened over a year, this is less than a day. This is 3 hours. The first detection, the first indication that we saw at Microsoft of Petya was actually on an internal Microsoft network in Ukraine. ATP, ATP was running, Windows ATP was running in our own office, and that was globally the first indication that we got. We got a piece of telemetry saying that we were impacted. Turned out they were running Windows 10, so nothing really bad happened. But the point of this slide is to show you how quickly these happen. This is an exploit-based attack, and as a result, things that evolve over time for months on social engineering attacks take place over hours in exploit-based attacks. AVs simply don't have an opportunity to respond here, and I will say that as a member of the research team who was associated with Petya response. Our research team did really, really well on Petya, but we were too late to save most of our customers from this. You really do need different techniques, behavioral techniques, cloud-based protection. We'll talk about some of those going on in the future. So we're going to change gears a little bit here and talk about a feature that's shipping in Windows 10 Fall Creators Update called controlled folder access. Every good talk has to have a demo. And when we tried to figure out what kind of demo we wanted to do, we first had actually talked about doing a demo of WannaCry or some other real piece of ransomware. Somebody pointed out that having a piece of ransomware that actively scans networks with 30,000 of our closest partners on the same network segment may not have been the smartest choice. So we wrote our own. What you'll see in the demo is a really good example that kind of follows the Locky path. This particular piece is non-virulent, but it shows you what you might expect to see and how we might protect you with controlled folder access and some other mitigations. Oops.
Thanks, Eric. No, not yet.
7, right?
Yeah, okay. Thanks, Eric. So today I'm going to demo 2 protections that we are shipping in the Fall Creators update of Windows 10. One is Application Guard, and the second is Controlled Folder Access. Now we will get to Controlled Folder Access in a bit, but first I will show you Application Guard. Here it all begins with an email, which is very similar to many other popular ransomwares out there. So I have been working with Eric for a while, and I see an email from Eric in my inbox. And I'm actually eager to open the email and see what Eric has sent me. Now, there are certain things that are suspicious about this email, like there's a URL in there that's not a corporate URL. It's a public URL. And it doesn't look like the email was sent from Eric's work email. Now, these things should throw me off, but most users don't pay attention to these details. And since I've been working with Eric, I'm actually eager to see what he has sent me. I go ahead and click on the URL. And since this is a public URL and not an enterprise URL, and since this device has Application Guard enabled, Application Guard notices that this is not a trusted enterprise URL and launches the session in Edge within Application Guard. So this is the Application Guard session. And it turns out that Eric actually uploaded a document and wants me to download this document on my device. So I go ahead and hit save, and looks like it's an Ignite presentation, which makes sense because we've been working on a presentation. So And what do we have here? It's actually a zip file folder. So I go ahead and hit extract. And what we have here is something that looks very similar to a PowerPoint presentation. It's got the same PowerPoint icon. Some users might catch on to the fact that it is indeed an application, but most users would not notice that. It's got a PPTX extension. It's got an icon that's a PowerPoint icon. So I decide to actually open and see what the PowerPoint has in it. So here, since the container notices that it's actually a PowerPoint extension, it's trying to reach out to the store to download the associated application, since there's no PowerPoint in the container right now. So I hit no, and when I try to actually run it, the container has code integrity policies that actually don't let this application to run. So that's great. The container did the right thing. I mean, application guard did the right thing. It put the untrusted URL in the container, and then it actually didn't let me even run this untrusted application. That said, say if this application actually ran in the container, your host would still be secure because this container has its own, it's an isolated session, it has its own kernel. So even if there's a kernel exploit, it's pretty much restricted to the container and will be flushed out when the container is recycled. But what if I'm an admin user? Yeah, so just to make that point, this window is, Edge is running within a container in this window. It's going to be on enterprise. I believe we're also going to bring it on pro.
Yeah.
Eventually. So pretty powerful stuff. But what if I am an admin user? How many times does a user try before giving up? And especially if it's an email that they think is from a trusted entity.
I wouldn't send you ransomware. That's impossible. You should try to open it.
Right. So, and there may be another scenario where, say, application guard was not enabled and the user has Chrome. So I fire up Chrome and try to navigate to the same URL. Just a second. So it's the same zip file that I go ahead and extract. And I try to run this application again. So this time, I see, just a second. Yeah, so what happened here was, what you see here is the smart screen dialog. Some of you might have already seen this because it's been part of Windows for a while now. And Smart Screen is trying to discourage me from executing an unrecognized application. And the default is set to don't run. But like I said, I'm one of those users who's an admin's worst nightmare. So I go ahead and run anyway. But before I do that, let's see what an untrusted piece of software can do to your system. And it could actually cause a lot of havoc on your system. In this case, we have some files that we care about on this system. You might have your documents, you might have work stuff, PowerPoint presentations. On this device, Eric happens to have, one second.
Just open it.
Yeah, it's Windows. So on this device, Eric has pictures of his daughter.
This is Sonia. She's 11 months old tomorrow.
And Eric would be mad if he loses these pictures.
I've got thousands.
So, so let's just see what happens if I run this application. Oh, this is still the store code.
You're in the container there.
That's the container.
Which still works.
Which still works. Yeah. So, yeah. So I go ahead and say run anyways, which is not recommended, obviously. And what I notice here is this application is encrypting my files very similar to what some of the popular ransomware attacks would do. And yeah, so I've basically lost all my pictures and probably a lot of other data that I care about. And here I have a message from the ransomware author with a ransom note asking me to pay 3 Bitcoins to recover my data, which turns out is not always successful.
I think that's fair for Sonia pictures.
So let's see if the outcome would have been any different if we enabled one of the features that we are shipping in the fall update, Windows 10 Creators Update this fall. And this feature is controlled folder access. So I go into Windows Defender Security Center, which is the app that has all the security settings of your device that you can monitor and configure. So what I do here is I go ahead and turn on controlled folder access. Just one switch of this knob. You can also deploy this in your environment with policy. It supports ADMX, MDM, Intune, and SCCM deployments. And before I run this application again, let me replace these files, since I have a script to do that, luckily. So here we have the pictures back again, and I'll try to run this application once more. So this time, looks like we will have a different outcome. Here, what we see is that the ransomware application basically could not make changes to the protected folder that's protected by controlled folder access. And we get a notification that Windows Defender actually blocked untrusted changes to the protected folder. Now, even if you have marked an application as trusted, or even if it's a default application that is trusted, Windows Defender would still block it if, say, the application gets tainted after it's run, which can happen in certain cases. So here you've seen another layer of defense that would help put you and your users in a better position to deal with some of these recent attacks. Back to you.
Cool. Thanks, Yolando. Controlled folder access is a great feature. It's sort of a blunt instrument at times. I would definitely recommend everybody take a look at it. There's a lot of scenarios where it's a really valid piece of tech to deploy. So back to my favorite topic, which is Petya. I'm going to go through this relatively quickly, but this is an internal diagram that we put together for how Petya worked. We'll go through it quickly. We'll talk a little bit about some of the defenses and some of the protections we offer. So number one, Petya came down from a software updater. There was a company called Medox in Ukraine. If you did business in Ukraine, you probably had their software on your machine. Somehow their software updater got compromised. Somebody injected a script in there that would come down with the software when updates ran. So update ran, script ran, downloaded malicious DLL, did its job. That's how victim 0 within a subnet got infected. The infection that it did, and the sort of the logic that Petya had in it, was actually pretty advanced and pretty interesting. The first thing it would try to do is encrypt all the user files, and that was a pretty typical scenario there. But simultaneously, it was actually trying to update the MBR, the master boot record, the thing that allows you to load your operating system. And there was some logic in there that was antivirus scanner dependent. If you had Kaspersky, it did one thing. If you had Symantec, it tried to do another. As to why, we don't really know. The general feeling is that it was for evasion, so that some of these AVs were either better at detecting it or not. But if it ran, it encrypted your files, it trashed your master boot record, and then it sort of switched gears a little bit. The way it was set up to work, it registered a reboot in the system, and it gave itself between 0 and 60 minutes to go out and try to replicate, try to scan networks, steal passwords, move laterally via any number of attack mechanisms so that it would actually spread not just through an email vector, but through the network vector. And that is why it was so fast. The particular exploits that it used, you may have heard about them in the news. These were developed by the NSA, Eternal Blue and Eternal Romance. Not going to go into the details there. Suffice it to say that Microsoft had patched all of our systems down to Windows 7. Actually, I believe Vista was included far prior to this. So if you had updated your patches, you would have at least been protected from the lateral movement aspect of things. Not everybody did. We see this now today in our telemetry. People have still not applied the patch for the SMB exploits. Please do that. Helps everybody. There's really not a reason today to be using SMB1. Turn it off if you can, which you should be able to. So in the last couple of minutes here, and it's going to have to be fast because we're running out of time here, I want to walk through what would have happened if you had applied some of these mitigations that we have. First is device guard. There's actually another name for this now called application control. If you had deployed it, it would have blocked that malicious DLL from being executed on the machine. It would not have been whitelisted. We have something called Secure Boot. Secure Boot ensures that only a legitimate operating system can boot. We have the Windows 10 kernel hardening. If you'd been running Windows 10, you would have been protected even if you had not applied the patch. I should say Windows 10 Threshold 1 version to be clear. CredGuard. CredGuard puts your credentials sort of in a lockbox. It uses virtualization technology to do this. You still could have been encrypted, you still could have been vulnerable, but CredGuard would have stopped the lateral movement because it would not have been able to enumerate the credentials, which is what it used to log into other systems. Device guard, again, on the remote system would not have been able to run. And finally, controlled folder access. If you had a controlled folder access, the encryption state would have failed. Quickly on recovery.
So Eric touched upon Microsoft's approaches to deal with ransomware, and the last approach in that funnel was recovery. So recovery is going to be one of our critical strategies going forward to deal with ransomware. Now, recovery is really very commonplace. I'm sure a lot of you are already using recovery, backup and recovery solutions out there. And recovery should not be scary. I mean, think about a scenario where you drop your iPhone in the lake, you go and buy a new phone, you just get all your data back, and you're probably happier because you have the latest iPhone. Now, one of the messages that we want to pass along is that you definitely want to consider a cloud backup story. You want to be able to test it, monitor it, and make sure it works when it's needed. And we on our end are going to make it easier for users to do a self-service recovery in situations when they need to, and they don't need to flood help desk with calls and flood maybe their backup providers with calls. And one of the examples where we've actually improved the recovery experience is OneDrive for Business. Some of you might have already seen this slide. So OneDrive for Business has built an experience where a user can actually visit the OneDrive web application and visit the restore experience. And they have a simple slider that lets them basically move back to a point in time and carry out a bulk restore. In this case, if you see there's a spike of writes on the right of the screen, and when the user slides back to the first write, a spike of writes, you notice in the revision history there's a file that was encrypted and marked as .WannaCry. So it's something that a user can actually go and trace back the revision history and just hit restore. It takes some time to restore. By the time they go and maybe get a coffee refill, their data is back in a good state. So the idea here is ransomware does not need to be a catastrophic event. It can just be a mere annoyance. And that's what backup and recovery would help you do.
All right, we'll do 1 minute on looking forward. This is always the sort of thing that you sort of wonder where things are going. Whoops. All right, we're out of time. In terms of looking forward, we're already seeing people doing doxing attacks, Internet of Things attacks. If we're successful in taking the financial motive out of decrypting files, you probably should expect the bad guys. They still need jobs. They're going to go after other things. You want to drive your Tesla, pay us ransom. You want us not to take all your business secrets that we've stolen from you and put them on the open internet. All of those sorts of situations. So thank you all for being here. We actually have some swag if you want to pick it up. We've got lots of it. There's bottles, there's things. Thank you.